cannot sleep yet. Okay, to flag problem solving Nernst equation. Okay, this one. Calculate the voltage of the cell, magnesium solid like this. Phase boundary, magnesium aqueous positive 2, 1 molar. Okay, the salt bridge boundary, CD positive aqueous, and 7 times negative 11 molar like this. Okay, so this one, guys, is the cell notation, is the left hand abbreviation for for the half cell reactions, anode and cathode. Okay, so it's here the like that, and also metal, cadmium, and magnesium. Okay, like that. So there's a concentration. Okay, so this is the cell notation. Okay, this is the cell notation. So this one, okay, and the other one, sorry, this one and this one. Forgot to put the CD solid here, huh? There's still another CD solid here. Okay, this is, and this one, two. Okay, vertical lines are salt charge of the balance. Maintain the the charges to be balanced, something like that. Which usually it could be sodium chloride or whatever. Okay, depends. Okay, all cell notation have salt bridge. Okay, so in here, so in this part is the anode and this part is the cathode. Okay, so let's break this one as here. So MgS, so if we can understand. So Mg aqueous positive 2, 1 molar like this. CD positive 2 aqueous, and then 7 the aqueous solution could either be a cadmium sulfate or magnesium sulfate. It was not mentioned, but anyhow we can understand that this is the anode and this is the cathode. Okay, like this. This is the anode and this is the cathode. So in here guys, so this is the anode, it is cathode. Automatically we are basing for the charge positive 2 of magnesium here and positive 2 of CD. So automatically we can determine our our anode and cathode, right? So our anode is Mg aqueous positive 2, and our cathode is CD positive 2 aqueous, like this. Anode like this, Mg positive 2 aqueous, cathode CD positive aqueous, and we still don't know which is the product and which is the reactant. Okay, unless you will be able to get the standard reduction potential. And now we go to the SRP or something. So chaos. So standard reduction potential, meaning gain of electrons of plus 2 electrons to Mg. Okay, for this. So we need to get this standard reduction potential of magnesium. Okay, so it's gonna be wait. Since I don't have book or any other sources or reference materials, you have to Google search the reduction potential of magnesium. Okay, type standard reduction potential, something like that. Okay, so Google standard reduction potential table. Okay, like this. We need to obtain that one. So let's see here. Always encode standard reduction potential. Magnesium positive 2, right? if there's a cell rotation, it's very easy to detect the anode and the cathode because what comes first is the anode and second is the cathode. Okay? So let's use like this. And let's check what is the magnesium. Oh my god, magnesium positive 2. Okay, magnesium positive 2 is negative 2.37. Really? Yes. This is negative 2.37. Okay, magnesium has negative 2.37 voltage as V or potential basing on the standard reduction potential at 25 degrees Celsius stable. And now we get also the cadmium positive 2 reduction potential. So this is still reduction potential of cadmium. So cadmium positive 2 aqueous, okay, plus 2 electrons, cadmium solid. So what is the voltage of cadmium? Reduction potential also because we're referring to reduction potential. So pareho na siya. Okay. So what is the CD? Cadmium, cadmium. So for this one, it's under reduction potential. Okay. Cadmium. So it's very difficult for the cadmium, right? Cadmium. Oh, where's the cadmium? Here. Here we have cadmium. CD, or is the cadmium? The cadmium is negative 0.40. Okay. Cadmium positive 2. Okay, cadmium is negative like this. Now, this need to distinguish, okay, for this, okay, which is really an anode or a cathode, okay, like this for the standard reduction potential. But we know in the cell notation that's gonna be our anode, Mg positive 2, and cathode CD positive 2. Let's prove that one here. Okay, so in theory, the less voltage or potential is the anode. So this is the, which is greater, lesser, negative 2.37 or negative 0.40. So since this is negative, the greater value will be the less potential, this one. So our anode is Mg2. Okay, Mg2 also. And our anode here is this one. It's because less voltage or potential, automatic the anode is correct, right? It's agree. So the other one will be automatic reduction because it has a less potential. Oh no, it's more potential than the magnesium positive 2, which is the cadmium. The other one automatic cathode. Okay, like that. Okay. Now since they are both reduction potential, okay, now we have also the anode here. So anode here is like this, but this is not the reduction. Okay, we have to reverse this anode and this reduction potential so that it will become an anode and oxidation. Okay, or else you cannot add the 2 and the electrons will not be cancelled. If you add the 2, if those are reduction here and reduction here, so the other one was the oxidation because this is already a reduction, gain of electrons. This reaction of the cadmium is already correct. So all we have to do is to reverse the anode because it's reduction, not an oxidation. Okay, so if we try to reverse this one, okay, so this negative 2.38 will become positive now. Okay, this is, so like this, we will reverse this one. So magnesium solid is equals to Mg positive 2 plus 2 electrons. Now it will become 2.37 voltage anode. So upon reversing this reduction potential to oxidation, so it will become now positive 2.37. Okay, sorry. So the whole reduction into oxidation 4 Mg positive 2. Now you can now it will become like this. Okay, wait now. It will become like this. So the anode will be Ms solid, Mg solid, sorry, Mg solid is equals to Mg positive 2 chaos plus 2 electron. It will now become 2.37 voltage, and this is our anode. And yes, upon reversing the reduction potential of the combination positive 2. Now we have the CD positive 2 chaos, which is a reduction or cathode, plus 2 electrons equals to CD solid. So our voltage is still the same, not to reverse, okay? Because we reverse only the anode, no, the reduction potential of Mg. Okay, so 0.40, this is the cathode. Okay, now add the two half-cell reaction. The electrons will be cancelled because the other electrons in the product, in other words, chemical reaction will be Mg solid plus CD positive 2 chaos, okay, is equal to Mg positive 2 chaos, okay, plus CDS, okay, like this. Okay, now in here, so we have Mg2. Mg2 is our, okay, Mg2 is our anode. See here, Mg is our anode, right? This is our anode. Anode, okay, or the product. Okay, this one. So our anode or the product, and then our and the cathode. Cathode and the reactant. This one. This is the chemical of our electrochemical reaction. This is our reactant R, and AGC. This is our cathode. So CD. So CD positive is the cathode. Sorry, cannot see because I reversed the paper. It's in here, right? Cathode. Our CD positive is the cathode. Okay, ganon. So our anode is Mg positive 2 or the product. Okay, now like that. So if we add the two halves of reaction, we also add this two potential or voltage for the two. So our total voltage or our E at standard, it's like this. Cell, electrochemical cell at standard potential is equals to add the 2.37, sorry, 2.37 plus 0.40, 2.37 minus 0.40, 1.97 voltage. This one. Our standard electrochemical cell potential is equal to 0.27 by adding this 2 here, okay? The potential here. Okay, like that. So we have 2.37 plus 0.40. This will be the result. Okay. Now to calculate the voltage here, this means that E electrochemical cell potential not standard. The E without the small circle at the top, so it is not standard. Okay. So the standard is always at 25 degrees Celsius, in which we obtain the SRP or standard reduction potential. Okay, and now we use the Nernst equation. Okay, there are two Nernst equations. Okay, this is like this: E cell is equals to A standard cell minus 0.0591 and the logarithm of the Q. Okay, the logarithm of Q. Okay. Okay, this is the logarithm of the Q. Now our Q is the reaction quotient, the product over the reactant. Okay, so Q is equals to product over the reactant or the anode over the cathode. It's in here, right? We labeled that already here. Cathode reactant R is a CD positive 2. Okay, and this is the anode is our product P. So our concentration of the anode is given in the cell notation. Our anode is the Mg positive 2 here. Our Mg positive 2 have the concentration of 1 here. So substitute that here, and this Mg2 is your anode. Okay. So this is 1 molar. So how about the cathode? Okay, product over the, okay, and then anode over cathode. What about the cathode? Our cathode is CD positive 2. Our CD positive 2 concentration here is 7 times 10 to negative 11. Okay, it's here, right? Here. So we have 7 times 10 to the negative 11 molar. So it's gonna be like this. Since this is the Q, we should substitute this whole thing here. Okay, let's substitute now. So E cell is equals to E substandard cell voltage equals to 0.0591. Now what is our N here? Our N here is the balanced electrons that we cancel. Is 2 for the anode and cathode. So divided by 2 times the Q, which is logarithm of 1 molar and 7 times negative 11 molar. Cancel the molar like this. Okay, and we have the E standard, which we computed already here also, which is equals to 1.7. Substitute that here. Okay, so it will become now 97 minus, okay, 0.0591 divided by 2 is equals to 0.002955. The logarithm of 1 divided by 7 times 10 to negative 11. Okay, so logarithm of 1 divided by 7 exponential to the 11 is equals to times 0.02955 is equals to, so okay, 0.3001. So 1.97 minus 0.3001. So our E cell is equals to 1.699. Okay, after solving this equation here, okay, there are values here, right? So our E cell is equals to, oh gosh, our E cell is equals to voltage, not at standard temperature. So E cell is equals to 1.6699 voltage. So this is the answer. E cell 1.699 voltage. Now we have the standard of how much ganito? Standard cell na itong nakuha. Okay, that is wait, we have that one here. So that is 1.27, right? The problem. So this, our E substandard cell is 1.27. Let's compare the two. Okay, the E cell not standard is less than the E cell substandard. Why? Okay, because our concentration of the product, okay, our concentration of the product anode, okay, our concentration of our reactant cathode, sorry, cathode reactant with CD positive 2 is 7. CD positive 2 concentration is equals to 7.0 times 10 to the negative 11 molar, right? And the CD is our reactant and our cathode. Okay, like this. And our Mg positive 2 is equals to 1 molar. Okay, this is gonna be the product and the anode. So we obtain a less E cell compared to our substandard cell because our reactant and cathode is higher than our product anode. Okay. If we increase the R, okay, reactant or cathode, okay, we decrease our P, okay, anode. So we increase our E cell. Like this. If we increase our, okay, reactant, okay, like the cathode, then our P anode will be decreasing. So we can show that here the concentrations, okay? And then our E cell, not standard, will also go up because it is directly proportional to the reactant, okay, here cathode. Now, so therefore E cell is less than the E cell substandard. So therefore E cell is less than to E cell substandard, in which this one E cell is is less than is E cell is high. Okay, our E cell is 1.67, so meaning to say bali ni siya E cell is less than the E substandard cell. Sorry, like this. Gamay siya. Okay, like it, because our reactant is like this. Okay, so again, if we increase the R cathode, our P anode will decrease. Our E cell will increase also. Our R cathode, how much? This cathode is 7 times the negative 11. Sorry, this negative 11 is less than man sa sa product. Okay, so this cathode, okay, or R is less than. So R down, sorry, nailad ko sa negative 11 na exponent or sa 7. Okay, actually 7 times negative 11, that the exponent is negative 11, the other is 1. Of course, 1 molar is greater than 7 times negative 11. Sorry po. Okay, so like this. So R, which is a cathode, is 7 times 11 molar, is less than the anode, which is 1 molar. So it's gonna be R down, okay, cathode down, okay, and then the P will go up, okay, anode, and then our E cell will also be going down. So our E cell going down, it's correct here, E cell is going down because E standard is greater than E cell, and E cell is going down because of our reactant is going down, okay, reactant meaning cathode, okay, product meaning anode, correct ba? Okay, like that, and then it's gonna be like this. Okay, so muna siya nahitabo. Okay, so therefore we can say that E cell, okay, is less than A substandard cell. Okay, like this for this reaction. Okay, E cell is less than the standard, in which here, because the reactant cathode is going down, the anode is going up, and then the E cell also will going down because R cathode is directly proportional to the A cell. Something like that. This is a theory. That's why we need to review the theory so that we will not be wrong. Okay, something like that. Okay, now this is using the using equation like this, ha. Okay, like this. We use this equation like this, but there is also another equation that would yield the same answer, which is E cell not standard is equals to E cell standard minus RT and FLN of Q. This one, the other formula to be used also in Nernst equation. E cells was so E cell standard minus gas constant universal 8.3145 joules mole Kelvin. Temperature will be 298 Kelvin, 25 degrees Celsius plus 273. And then F Faraday K96485 coulomb mole electron, and this is the number of electrons, and L and the Q is again the same what we did in the other equation. So product over the reactant, okay, and anode over the cathode, something like that. Okay, like that. And what is confusing to this also, okay, if you don't want to use this formula, this is second formula, right? If you don't want to use this formula, use the other one. But this is more tasky because we need to substitute the R, the T, the N, and the F. So I would rather use this logarithm rather than the natural logarithm. This one, the other one, okay? Because, which is that? Nawala. Okay? Because, ako na lang isuwat, okay? Equals to A cell like this, 0.0591 and logarithm of Q. Okay, so I would rather use this logarithm rather than the lny because there's already the standard value of 0.0591. Here too much, substitution R, T, and F. But if you want to do that, it will yield the same answer. Okay, these are all Nernst equation. Okay, so in here, in our problem here, calculate the voltage. Okay, like that. Calculate the voltage, meaning the E cell, not the standard. Okay, the standard E cell is always coming from the SRP, standard reduction potential of this magnesium and CD positive 2, like that. Okay, so the theory is always correct, and the solution, your solution will adjust. Okay, like that, because in here your reduction or cathode, okay, is CD positive 2, which is 7 times 10 negative 11 molar concentration is less than man siya. So your E cell also will be less than to your E cell standard. Okay, like that. So in here, if that is the case, so our delta G also matters a lot for that. Okay, so our delta G will be if our E cell is very less, so meaning our E cell is negative, so this is non-spontaneous. Okay, like that. If our E cell is less than positive 1, and this is not less than positive 1, right? This is 1.6699 voltage. Okay? So if our E cell is negative, and this is not negative, right? So this is non-spontaneous. Okay? Okay? Like that. Because spontaneous is we obtain negative delta G, and our E is always negative, something like that. Am I correct? Okay. No, it's the reverse, sorry. Okay, if you have a spontaneous chemical reaction, electrochemical reaction, delta G is also negative, your E cell is always positive, something like that. Okay? Ganun siya. Yun lang. But guys, if you want also the other one, this is really confusing, guys, because you know, if you use the reverse of the Q, which is reaction quotient Q, right? So sometimes it will not be P over R. It is R over P, and R over P cathode over anode, something like that. Diba? R is cathode. When the formula here is libog ka siya, guys. Okay? If it is positive here, like this. If this negative will be positive here, so the Q will be adjusted here. Instead of P over R, it will become R over P, okay, cathode over anode. And here also, R over P, okay, cathode over anode. Okay, so reactant over P. So in order you will not be confused, just use the negative consistently. Anyway, it will yield the same answer also. Because other reference based on my research, they have a positive here. And then it confuses me a lot. How they do this? How did they do this that is positive? Since I derived the equation from Van 't Hoff's equation. Remember that Van 't Hoff's equation? Charot. Okay, it will yield a negative talaga siya, not positive. Because your reaction quotient is adjusted. Okay, so be careful. There's an equation like this also, positive. Two equations of Nernst equation is positive. And there's also negative, minus. Here, the original one is the minus based on the derivation, but it can also be correct positive. You will just adjust the Q. Here, okay, just like the Arrhenius equation. Okay, instead of, 1 over T2 over 1 minus 1 over T1, if you don't want a negative activation energy, right? Then if you want negative activation energy, then you have to 1 over T2 minus 1 over T1. Sometimes it confuses a lot if you memorize the equations. If you don't understand, then something wrong, because the T2 will be replaced and will be on the other side, and the other side, it will yield, something wrong. Okay, something like that. It's very, very important to derive. You know how to derive. Okay, something like that. Okay, thank you so much for watching my live streaming, and I have to end my live streaming. I have to have another one. Okay, after this, which is the derivation of Nernst equation from Van 't Hoff's equation. Thank you so much, guys. If you like this video, you can comment down below in the comment section. Then you can subscribe my YT channel, and you can click the notification bell for some newest updates of I Am a Singer, Eternal Voice. Bye bye. God bless everybody.